Hello, Keith Rucker here at VintageMachinery.org. So we got a little, I guess you call this a rush job or semi-emergency job out here at the museum that we need to take care of. And this is probably going to be one of those situations where we do a quick fix and then we do a long-term fix. And the long-term fix is going to come down the road, and we're going to prepare to do that. But we do have some things we need to take care of immediately. So what we're dealing with here, these are the bearings off of our steam locomotive, and we've got some issues with them. I'm going to take you out here and show you on the locomotive what they look like, and then we'll come back in here and look at these and tell you what we need to do. So this is the Georgia Museum of Agriculture's 1917 Vulcan Iron Works steam locomotive. It was built in 1917. And it's basically a little small industrial engine, narrow gauge, 36-inch, and we use it out here at the museum, give train rides, and use it to interpret what a logging railroad might have looked like in the late 1800s, early 1900s in this area. So as you can imagine, with a piece of equipment this old, almost 100 years old, there's always maintenance and issues that need to be done with this, and we're in a situation now where we need to take care of some stuff, and that has to do with the bearings on these connecting rods. So the steam engine is up here, and of course this is going back and forth. This piston goes on. There's a slide here that goes back and forth that keeps it all level, and then there's a rod that goes down to the back wheel, and of course that is going to go around in a circle, and then there's a connecting rod that goes from the back wheel to the front wheel, and the issues have got to do with these bearings down here. So let me zoom in on that and we'll talk about what we need to do. So on the locomotive wheel, there's a pin that comes out, and in here is just a turned pin on the inside. You got some flanges in here that don't move, that kind of position these laterally so they stay in position. And then around that pin, you got two halves of a brass or bronze bearing that are on there to keep, basically a bearing surface on there that's oiled. There is the screw here, and the screw here actually goes down. There's a wedge in here. There's a wedge cast into the actual bearing, and then there's the opposite wedge on there. So when you tighten this bolt, basically you're tightening that wedge, and that squeezes this thing together. So you can adjust for some wear in these over time. Our situation is twofold. On the other side, this is the side that's a lot better. But on the other side, we've got some issues with the wedges. One of them has a broken bolt, one of them has a stripped bolt, and we've started hearing some knocking, and we've determined that that's the issue. But secondary, these actual bronze or brass bearings in here, they have become very worn over the years. They're still usable as they are right now, but on a couple of them, we're getting down borderline as to when, we're going to basically have to replace these. So short-term fix, we're going to take care of the wedge problems, and we're going to take you in and show you that. Long-term fix, while I got these apart, I've made some measurements and drawings of these brasses, and we're going to make some patterns up and probably have some new bearings cast in silicon bronze, and we'll machine those out, and down the road, again, that's not a pressing, but we're going to go ahead and take care of this, at least to do the measurements and get some parts on hand so that as needed we can fix those down the road. So now I'm going to take you in, we'll show you these parts kind of taken apart. So you're going to see there's a kind of a U-shaped strap that goes around here. This is the actual connecting rod, the U-shaped strap. There's two tapered bolts that go in here that when tightened up, it actually tapers and locks this into place, and then the front brass here is just flat up against that, and again the back brass, we have the wedge in there that we can adjust. So this is one of the bearing assemblies that we've pulled off of the opposite side of the locomotive, and again, there's two issues. We had to take two of these off, and both of them have to do with this wedge. So again, if you look on the back of this bearing, this back surface in here is an angle. That's an 89-degree angle, so about 9 degrees off of a 90, and you have the wedge in here. And again, this wedge rides up in here, and as you tighten that up, as it moves up, it's going to, move this bearing. As it moves up, it will move that bearing in and tighten it up and loosen it up, and there's a bolt that goes down through here to do that. So the two issues, and it's different on each of the two wedges. One of them, the wedge itself, this one here, I believe this is an original wedge, but the threads in here are partially stripped out. You can take this bolt and drop it down in there probably 1/2 of an inch before it even hits any threads, and when you do get down in there, they're just not catching. So this one here is actually it's kind of creeping. It's because the threads just aren't holding in there. So we're going to have to make a new wedge to go in the back, and this is going to be a fun little part to make. We got some radiuses in there, we got an angle on here, and that's going to, we've got to make a new one of those. The second thing is on the other side, the actual bolt that went down in there was stripped out. The wedge itself is a replacement wedge that was made at some point in time. In fact, it's this one. The other one actually doesn't require radiuses on it because of the way it's designed, but this one here, the threads are great. Like I said, I think that's one that was a replacement, but the threads were worn out, so we got to make a new bolt. And these bolts that were on here were kind of cobbled together. This is a piece of threaded rod, all thread. They took a nut and just welded it on the end, and we're going to make a proper bolt out of some hex stock to fit that, and then we can put that side back on. And then, so again, 2 parts, or probably 2 videos. Probably gonna make the bolt first, just so we can go ahead and get one of them back on. Then have to make the wedge. Probably just gonna go ahead and make a new bolt for it while I'm at it. So we'll have fresh bolts on both of them. So that's the plan of attack. And let's get over on the lathe, and we're gonna crank out a proper bolt for one of these. So we're going to make these bolts. I got some 7/8 inch hex rod here, and I got this just in a 3-jaw chuck. We're going to start off by facing the bottom. This will be the bottom end. I'm going to put a little small center in here. It's so long and threading like that, I just feel a little bit better having some support out there. So I'll put a little center in here, and then we'll run this out and start turning it down. So first thing we're going to do is just make a mark on here for how deep we want to go with that. And I'm just using the old original one as a copy. So that'll be the depth of the threads, or the depth of the bolt. And just so I make sure I see that, I'm going to come in here and we'll put a little mark right there. Come back to this end, touch off. 10, 2, 4. And we'll start off with this being hex. You really can take a pretty heavy cut on that first. So this is about 160 thousandths total, but it's an interrupted cut. This should get us down to where we're cutting a solid all the way out. Let's go ahead and give it a try. Yeah, that's turning fine. The thread on this is 5/8 11, so let's see where we ended up at on here. So we're at about 825. We need to go 625. So we got 200 thousandths take off. I'll just go ahead and take another 100 off. Then we'll get another measurement. We're about 5 under. Got my threading tool in now. We come in here and start by just cutting me a nice little chamfer on the bottom and get a good angle down there to get started on. Come in here and touch off. I'm going to zero my compound. And we will start by doing a scratch test to make sure I got 11 threads per inch. So let's get around here on a number. Put my thread gauge out here, and that is 11 threads per inch. Take my compound back to zero. I'm going to feed in, and we'll make our first pass across here. I've done a couple of videos where I talk about threading, so if you're interested in this process, you're not familiar with it, you can go back and watch some of my other videos, and I will go over the process in detail on how to do threading. I'm not going to thread it all the way up to the top. We're going to stop about right there. Go back to zero, and we'll feed in a little bit more on our compound. And engage. Pop that one in tape. Let's do the next one. There we go. Sometimes that half nut just doesn't feel right when I close it, and if it doesn't, I pull it out and I'll wait for the next number to come around on my thread dial. I'd rather make sure I hit it right. This is an old lathe, and that half nut's not perfect anymore. Feels pretty good. I think we're just going to go with that. So now we're going to come in here. I just cut this off on the bandsaw, so we'll face the top of that and speed it up a little bit now. And I've just got a little cutter here with a angle on it, and I'm gonna come in there and just kind of break the corners around there on the top so that we have a circle around there. Just kind of finish out the bolt, give it a nice, good looking appearance, and break those sharp corners around it. That's good. All right, so we got the bolt made here. This will fit this wedge, and we'll go ahead and reinstall this bearing on the locomotive, and then next job I need to make this new wedge like I said before, and probably do that as a separate video. I'm gonna come in probably tomorrow and try to knock that out, and we'll just save that as a separate video for you guys to watch later on. So we'll get in here and make these other wedges. Probably show you putting it back on the locomotive as well, just so you can kind of get a better idea of how it all goes back together. And the brasses, again, that's going to be a project for down the road. I've got all my measurements. I drew these up. I know what I need to do. I took plenty of pictures of these. So we're going to probably make up some patterns and send these off and have them cast out of silicon bronze. Cattail Foundry, who does a lot of our foundry work for us out here at the museum, can do that for us, so we'll probably just send those up there. And once we get those castings back, we'll machine some new brasses to go in here. We'll probably just do them one at a time. Each one of them, the bores in here has got to be bored out to fit the bore on the locomotive, or the size of the pin on the locomotive. And because of the wear over the years, they're all going to be a little bit different in size. I had two of the pins out, obviously, when we took these, and I went out and mic'd them, and I was very pleased to find out that they're round. I was worried that they were going to be kind of worn egg-shaped or eccentric or something from the pressures being a little bit greater on one side or the other, but the brasses have done exactly what they're supposed to do. They protected the pins. Although they are worn, they've worn evenly. One of them, I'm making assumptions on what the nominal measurement would have been on them, but one of them looked like it had worn down about 100 thousandths, and one of them had worn down around 50 thousandths. Rough numbers there. But again, we'll mic those up, and we'll bore these out to fit when the time comes. And that'll be, again, it'll be a project down the road. We'll look forward to having at some point in the future. So that'll be a wrap for today, and we'll try to bring you making the wedges in an upcoming video. It'll be mostly milling machine work.